This is an overview video of the OpenPrismNode. The OpenPrismNode, or OPN for short, is a software which reads and writes Prism DITs to and from the Cardano network. It can be used as a drop-in replacement for the original Prism node by IOG when using the Hyperledger Identis Cloud Agent, or as an Identis-independent software to resolve or even create DITs just by API calls. It offers a simple setup using a single Docker Compose command and can be either used together with dbsync or the BlockFrost API to read data from chain. It offers a UI to control the sync process, statistics API, and a tenant-based wallet management system to control the payment of the Prism on-chain metadata transactions. In this video, we will go over the basics of syncing the node using dbsync as well as the BlockFrost API. We will then demonstrate the DIT resolution API. After that, we will go into the requirements for writing DITs, the process to set up a wallet and use the Identis Cloud Agent, as well as the Universal Registrar compliant API to create DITs. Let's start with the most simple setup, using the BlockFrost API as a data source. We open up a terminal and create a new Compose file and copy the contents from the documentation over. Before starting the node, we should change a few things. The API keys or passwords for the public access and the admin key, and the BlockFrost API key. After that, we can start the sync process. This will now take a while. If you don't have a paid BlockFrost subscription, this will also hit the daily limit quite quickly, but you can leave the node syncing. When the daily limit resets at midnight UTC, the sync will automatically continue. Meanwhile, we can already open the UI of the node at port 5001. Let's log in with the admin API key. You can now see the current synchronization state. When the sync is complete, you can use the node to resolve DITs. But you might have seen the yellow notification. Since the Cardano wallet wasn't set up, you can't use the node to create DITs. So let's change that. To set up a node using dbsync, you can start afresh, or you can continue with the already half-synced node. Switching the method from BlockFrost to dbsync or the other way around can be done at any time. Let's change the configuration or copy the Docker Compose file from the documentation again. The configuration is nearly similar, but we have to change the sync data source provider to be dbsync and add the dbsync Postgres connection string. This assumes that you also installed the Cardano node in dbsync. Here you have to point the node to the Postgres database, which comes with dbsync. Note that this doesn't have to be on the same machine. With these changes, we can already restart the node and it would start syncing. And you could immediately use the node again for resolving DITs. But before we continue, let's also add the configuration for the Cardano wallet. If you already have a Cardano node and dbsync running somewhere, it's quite easy to also run the Cardano wallet. As before, this doesn't have to be on the same machine as the OpenPrismNode. So let's make these changes and start the node again. It's already thinking again. And now we have to wait. This might take a few hours. But after a while, it's completed. We can look again at the admin page to see that it's indeed done. Now, let's resolve a DIT. I created one recently. We can now call the Universal Resolver compliant endpoint. we receive the DID resolution document in response. This is aligned to the Universal Resolver specification. If you are in general more interested in use the resolution results and don't want to host your own OpenPrismNode, you can also use one of our hosted services at opn.preprod.blocktrust.dev or opn.mainnet.blocktrust.dev. Or you can use the UI by going to statistics.blocktrust.dev. Now let's see how we can create a new DID. As I mentioned earlier, the requirement is that the Cardano wallet is hooked up correctly. If so, we have two options to create a DID, either by using the API or the Identis Cloud Agent. Let's start with the API, as this doesn't require any other software. The basic concept is that we first need to log in using the user API key that we set up in Docker Compose file at the beginning. This is basically a shared user, so you can share this API key to anyone you want. It does not expose any secrets, but it allows the user to create its own wallet inside the OPN. So let's do that for ourselves. We log in using the user API key. And then we give the wallet a name and create a new wallet. This creates an ordinary Cardano wallet in the background and immediately starts thinking the wallet. We also get the mnemonic phrase for that. So you should of course keep it safe. But as we won't use the wallet for any big amounts of ADA, this isn't so critical after all. The wallet is only used to pay for the creation of the metadata transaction to write DIDs on chain. If the wallet would be compromised, this would not affect the security of the DIDs in any way. But the other thing you have to write down is the wallet ID. We sign out and now we sign in with the wallet ID that is only known to you. We can now see the sync process and the current balance, which is initially, of course, 0. After the syncing is complete, we are provided with a funding address, which we can now use to fund the wallet. The creation, update, or deletion of a DID costs about 0.2 ADA, so usually there would be no reason to have really more than maybe 5 or 10 ADA on the wallet. Since this demo is showing everything on the preprod network, we are using the faucet to fund the wallet. After a short while, the funds are displayed in the wallet. This page will later also show all the transactions paid for by this wallet. So now let's create the DID using the API. We have to create a new request for that, which follows the Universal Registrar specification. But to get started, we just copy such a request from the documentation and simplify it a bit. The first thing we need to change here is the wallet ID to make sure that we are using our own wallet to pay for the transaction. Otherwise, we can leave it as you see it here. This should create a new DID with a single authentication key and a service endpoint. For the URL of the service endpoint, let's use the documentation of the OPN just for fun. Now we can send it to the OPN. What we get back is a job ID. As you know, writing to chain is not instantaneous and it takes a few seconds. We could try to resolve the DID, but let's use the job ID to call the endpoint again. The request would look something like this. What we now get back is a resolution result, but an additional secret section which contains all the private keys. The master private key, which allows you to make any changes to the DID, and which is needed for all subsequent calls, for example, to update or deactivate the DID, as well as the private keys, for example, to sign credentials with that DID. Since you are not using any kind of software SDK, you now would have to take note of this information, as this does control the DID. For more information on how to structure and handle the update and the deactivate request, have a look at the documentation. So what I've shown here is the manual process of resolving and creating a DID. Prior to the OPN, this wasn't possible at all, and you had always to go through the Atala Prism software, later renamed Adentis. This software has in the past only been running with a proprietary version of a software called PrismNode. The OPN is the open source alternative which can serve as a modern and more feature-rich drop-in replacement. I can't get into all the details of how the Cloud Agent works, but I can also set it up using a Docker Compose file. Here you can now replace the Prism node with the OPN. This could either be your own OPN hosted locally or a hosted service as we are providing. You can now start up the Cloud Agent and interact with the Cloud Agent as you would normally. In the background, the Cloud Agent would now use the OPN to create DIDs or resolve DIDs. So let's try that. We start the agent and call its endpoint to create a DID, and then publish that DID on chain. We also have to wait a bit for the result. As proof that all of this worked, we can now resolve the DID again. The main difference, apart from using a different software, which we are calling here with the Adentis Cloud Agents, there is that you don't get back the private keys that we got through the Universal Registrar API. Those are now handled inside the Adentis Cloud Agent. The other difference is that the communication isn't happening over HTTP, but using gRPC. So this concludes our overview tour of the OPN. For further details, please have a look at the documentation or get in touch with the Block Trust team, which are the stewards of this project. Have fun!